Hey, Travis. Thanks for that introduction. Good afternoon, everyone, and thanks for joining us today. As Travis mentioned, my name is Ryan Neville, and I'm the Vice President of KLa Systems, a company focused on jet aeration and mixing technologies for both industrial and municipal wastewater treatment applications. At KLa, we specialize in helping facilities increase oxygen transfer and improve aeration performance, often within existing treatment infrastructure. Today, I'm going to walk you through some of the challenges plants face when trying to upgrade aeration systems and how jet aeration and drop-in aeration technologies can provide a practical retrofit path for expanding oxygen capacity. With that, let's start by looking at what's happening across the water sector today. The real challenge plants are facing isn't just treatment performance, it's how difficult and expensive it has become to add capacity in a live plant. Across the U.S., wastewater infrastructure is aging and underfunded. The American Society of Civil Engineers gave wastewater systems a D+ grade in both 2021 and 2025, which tells us that the investment gap really hasn't improved. At the same time, existing treatment systems are being asked to handle higher loading and higher throughput. On the municipal side, the number of publicly owned treatment works has grown by about 10% over the last decade. And on the industrial side, we're seeing strong growth in sectors that require significant aeration capacity. Areas such as data centers, food and beverage production, brewing, and chemical manufacturing, to name a few. What all these sectors have in common is that very few facilities can tolerate extended shutdown windows, which makes system upgrades significantly more complicated. As a result, plants are increasingly looking for solutions that can improve performance without requiring a major capital investment or taking treatment facilities offline. Aeration is often one of the first places operators look. In many facilities, aeration accounts for up to 75% of total plant energy use, which means improvements here can have a meaningful impact on both performance and operating cost. But when it comes to shutting down basins to make those upgrades, the costs can escalate quickly. In some cases, plants are spending hundreds of thousands of dollars per day hauling wastewater just to avoid shutting down treatment capacity. So the challenge becomes, how do you increase oxygen transfer and improve aeration performance without taking the plant offline? When plants need to restore aeration performance or increase aeration capacity, there are usually several paths they can consider. The first option is a civil expansion or adding new basin capacity. That can solve the problem, but it's also typically the most capital-intensive and time-consuming path. A second option is to add chemicals or some form of supplemental treatment. This can help in certain short-term situations, but it often adds recurring operating costs and may not address the underlying aeration constraints. Plants may also look at replacing blowers or increasing blower capacity. In some applications, this also makes sense, but if the issue is limited transfer efficiency or poor mixing, adding air alone may not fully solve the problem. Another common approach for plants utilizing fine bubble diffusers is rehab or replacement, which can improve transfer efficiency, but may also require basin access, cleaning, or other maintenance complexities that require downtime depending on the condition of the system. Every plant has options when aeration performance starts to decline, but the options that tend to rise to the top are the ones that increase oxygen transfer while minimizing downtime and simplifying operations. That combination is exactly what jet aeration systems are designed to deliver. Jet aeration is often a strong fit when plants have high-strength waste or challenging applications where these considerations are a primary focus. So let's talk about what the ideal aeration upgrade scenario would look like. Most operators would agree that in a perfect world, plants would be able to add oxygen capacity quickly, keep basins in service, and avoid costly shutdowns. Similarly, finance teams and managers want these plant upgrades to also minimize capital and installation burdens and have the flexibility to scale or redeploy the chosen solution as their needs change. Ideally, Those improvements would happen within the basins that already exist, allowing facilities to extend the performance of the infrastructure they've already invested in. Because the reality for most plants is that building new basins or shutting down treatment capacity simply isn't a practical option. So the question becomes, how do you achieve an increase in oxygen transfer and mixing performance within existing basins, all while eliminating major construction and disruption to current operations? Well, this is where KLa Systems comes in. At KLa Systems, our focus is very specific. We are the jet aeration and mixing technology experts for wastewater treatment. We were established in 2001 and are headquartered in Assonet, Massachusetts. Over the past 25 years, we've completed more than 1,800 aeration and mixing installations worldwide. That experience led to the development of our slot injector aeration system. At a high level, the slot injector system combines a slot-shaped nozzle configuration with low-flow, high-pressure liquid to provide increased oxygen transfer compared to a standard jet aerator. This is also what allows the slot injector to maintain high transfer efficiencies at a relatively low capital cost. Like a standard jet, liquid is recirculated from the treatment basin through the nozzles, where air is entrained into the flow, resulting in a high-velocity jet plume. Because the system uses both liquid and air injection, it can support aerobic or anoxic conditions independently, depending on how the system is operated. This combination of oxygen transfer and mixing is what makes jet aeration particularly attractive in retrofit applications, where plants with high-strength waste need to increase performance within an existing basin. At KLA, we generally group our solutions into 3 core configurations, each designed for a different operational scenario. On the left, you see our standard slot injector system, which is a fully engineered solution for custom applications where new construction is the desired route, or for existing plants where downtime for a system upgrade is built into the plan. On the opposite end of the spectrum, on the right, is our slot injector rapid series, or RS. This is a skid-mounted, crane-set system that offers our fastest deployment option in a standard aerator configuration. It is designed for situations where plants need to restore aeration performance or increase aeration capacity quickly, whether that's recovering from equipment failure, bridging a capacity gap, or reducing operational risk in the short term. Lastly, in the middle is our slot injector modular series, or MS. This is also a skid-mounted crane-set system, but the difference is that we offer the modular series in a custom-engineered configuration. It can be installed quickly and configured to fit different basin sizes and shapes, making it a good option when plants need increased aeration capacity within an existing footprint and don't have the luxury of downtime. So, depending on whether the priority is long-term engineered performance, rapid delivery, or increased capacity, our jet and slot options can be configured to match your operational needs. Every slot injector system is designed around 4 core outcomes. C is for consistent treatment results, which come from the option to vary both the air and liquid flows to maintain predictable and customized performance across varying loads. O is for oxygen transfer performance. This comes from the high-energy jet plume that provides increased oxygen distribution throughout the basin. R is for reduced energy and operating costs, which are achievable thanks to the unique slot shape and high liquid discharge pressure of our slot injector system, offering increased efficiency and capacity. And E is for enduring operation, which comes from a serviceable design that simplifies cleaning and long-term maintenance. To give a practical example of how this technology is applied, here's a project from a large hog processing facility in South Dakota. The challenge at this plant was delivering high oxygen transfer capacity across multiple treatment basins while still maintaining the flexibility required for both the nitrification and anoxic processes. To address the customer's challenges, the engineer chose our slot injector aeration systems for use across each of their 5 1 million gallon basins. The design for this plant utilized over 600 slot injector nozzles across the 5 basins, with 3 basins operating in nitrification mode and 2 in anoxic mode as mixers. As previously mentioned, the unique operation of our slot injector system offered the flexibility that the customer was looking for to achieve mixing and aeration independently while utilizing a consistent equipment design. Another benefit of this approach is equipment redundancy, since aeration basins can operate in anoxic mode and vice versa. The overall system was designed to deliver roughly 154,000 pounds of oxygen per day while maintaining strong basin mixing across the treatment train. The result is a system that supports the complete nitrification and anoxic mixing requirements for the customer's needs, while giving the flexibility to operate efficiently across a range of process conditions. Another example of how this technology can be applied is this project at a protein conversion facility in Turlock, California. The challenge at this plant was increasing treatment capacity to support higher production rates, all without expanding the facility footprint or shutting down the existing treatment system. To address those challenges, a slot injector modular series unit was installed into the existing basin. The basin originally operated with 64 injectors, and the upgrade added 16 additional nozzles, bringing the total to 80 injectors to increase oxygen transfer capacity by 25%. The system uses an integral 30 horsepower submersible pump to recirculate liquid through the injectors, while air is supplied by the plant's existing blower system, allowing the upgrade to integrate directly with the current aeration infrastructure. Because the system was dropped directly into the existing basin, the facility was able to increase aeration and mixing capacity without structural changes or process downtime. Those are just 2 examples of how every facility is different. So if you were evaluating aeration at your facility, here are the steps we recommend. First, identify where oxygen demand may be approaching the limits of the current system. From there, plants can evaluate retrofit options within existing basins to increase capacity. It's also helpful to compare the life cycle costs of different upgrade paths, including expansion, equipment replacement, or retrofit solutions. And finally, a comprehensive system assessment can help determine the right aeration and mixing strategy for your facility. If you're currently evaluating options to increase aeration capacity or improve aeration performance in your facility, we'd be happy to discuss this to see if KLA and IWS can offer any guidance. We typically gather a small set of information about the existing aeration equipment, how your process is currently performing, and the major operating costs associated with the process. From there, we run a facility aeration assessment that looks at asset condition, oxygen demand, and retrofit feasibility. The end result is a clear recommendation, whether it makes sense to keep the current system, optimize it, supplement it, or consider retrofit options. That brings us to the end of the presentation. Thank you for taking the time to join us today, and please feel free to reach out to KLA and IWS. We'd be glad to answer any questions.